Reflectional symmetry just means that I could draw a line somewhere, and when I draw that line, I would have the same exact thing on both sides. So let's see if I can, here we go. Let's take this smiley face. If I draw a line right down the center, that might not be the center, but I can move mine over. I have the same thing, exact same thing on both sides. If I look at this E, I could draw right down the middle. On the top and bottom, I have the exact same things. So the first two have one line of symmetry each. Let's look at this little figure. I have lots of them. I could draw right down the middle through there, and I have the same thing on both sides. I could draw right down the middle like that, and I still have the same thing on both sides. If I look, I have 3 little prongs on both sides. 1, 2, 3, and 1, 2, 3 prongs. If I put this one up and I take this one away, I have 1, 2, and 1, 2 prongs on both sides. There are lots of lines of symmetry on this. I could keep on going, and I could say 1 right through there, 1 right through there, through there, and through there. So there are lots of lines of symmetry. Alright, so how does symmetry work in triangles? If I look through here, I have a line of symmetry. It's the same thing on both sides. If I look over here, I have a line of symmetry. It's the same on both sides. And through right here, a line of symmetry. We know that this is really what you call an equilateral triangle. We could call it also equiangular, but we don't really refer to triangles that way. You could also call it a regular triangle, but for triangles we have a particular name. Okay, and I'm going to jump over here to the other end. This one only has one line of symmetry. Both sides would be the same. Additionally, I could say that this side is congruent to this side. We call this an isosceles triangle. And many of you know this already. This one, in the one in the middle, none of the sides are the same. This is what we call a scalene triangle.